Okay, the last session here. We're going to talk about scripting plots. And there's three things we're going to talk about in scripting plots. We're going to talk about basic plot creation, custom plot creation, and then plot modification. After we get done with that, we will be done and we'll review our objectives. So let's get started. You have to import the plot class or the plot module before we can do any plotting. So you're going to need this line at the top or near the top of your script. After that, you can somehow get your time series. You know, we can read them from DSS, probably some combination of reading them and modifying them. But regardless, we need time series to work with and be able to plot. So once we've got that, then we can say plot equals plot.newPlot. We'll talk about all the names plot here in a minute. This will create an untitled plot. If you want a titled plot, you can put the title in as a parameter to new plot. You can put it in as a string literal or a variable that contains a string. So now we add our data. And assuming we have two time series containers named TSC1 and TSC2, we say plot add data for each one. Now, just like in working with the time series math operations, where we needed time series math objects, when we are working with plots, we need time series container objects. So that's why I have here said TSC1 and TSC2. However, if you had time series math objects instead, if you remember from the previous session, we said we can convert those back and forth. So we could say tsm1.getData. Now we could capture that to a new variable, or we could simply put that whole thing tsm1.getData as a parameter to the add data and let it, instead of capturing to a variable name, simply capture to the parameter we are passing. Either way works. Depends on whether you have time series math or time series containers, but we have to add time series containers to plots. So we create the plot, we add data to the plot, and then we show it. That's all there is to it. But let's talk about all this stuff about plot. We've got plot everywhere here. And we've got capital P plot, and we have lowercase p plot. So Python, Jython is case sensitive. So the capital plot and the lowercase p plot are not the same variable. They're not the same thing. The script can differentiate between the two. If that bothers you and you don't like to use the same word even with a different case for a variable name, then you can call it something else. But I normally call all my plots plot, unless I have to address more than one at a time. And then I give them a little more descriptive name. But you need to make sure that you use capital plot for the plot class or the plot module, and then don't use a capital P for any variable name because it's already used by that. Okay, that's basic plot creation, and that will do it. So now let's go to custom plot creation. Ooh, got a bunch of stuff here. We start out the same way. We create a new plot. We could give it a title, but we didn't. But we start doing things differently here. Instead of adding data, we get a layout. We create a layout by calling plot, capital P plot, dot new plot layout, and capture that into a variable, and I usually call that layout. And within that layout, then we can start adding viewports to the way that we want them to be arranged. Viewports are always added top to bottom. So if you're adding multiple viewports, of course, if you're not adding multiple viewports, there's no reason to use the custom plot creation. So just remember that they're added from top to bottom, and you can give them an optional relative height. And so you can do this you can do this not by creating them by an existing plot. You can configure it interactively, and when you do that, the relative heights have to add up to 100%. There's no such restriction here on when you're scripting it. You can, if you're adding two viewports, you can set the relative weight of or relative height of 1 to 3 and the relative height of the next one to 5, and it'll just proportion them. However, the proportioning is approximate because there's other things that go into the plot other than just the viewports. So your mileage may vary. If you want one exactly twice the size of another one, 1 and 2 may not do that for you, or 8 and 16 or whatever values you would use. You might have to adjust those a little bit to get the look you really want. Okay, anyway, so we create a new plot, we get a plot layout from it, and then we add multiple viewports to the plot layout. For each viewport here, now we add a curve. Whereas before we added a time series container directly to the plot, here we add it to the viewport in the plot layout. And instead of add data, now we're saying add curve. And also we are given control over what axis this goes on. So if we give it axis name of Y1, it'll be on the left y-axis. If we give an axis name of Y2, it'll be on the right y-axis. And so this is a great way to script adding, stage and flow in the same viewport, but on different axes, or elevation capacity, or any two related variables. You can put them in the same viewport, but add them on different axes so that you can see the relation one to another. And just like adding in the basic plot configuration or a basic plot creation where we say add data and we go to time series container, we do the same thing here. In add curve, after the axis name, it wants a time series container object. Once we're done adding viewports and adding curves, then we say configure plot layout with the layout object that we created earlier. Then we call show plot. So it's not completely unlike the basic plot creation. It's a little more involved, but it gives you a whole lot more control over the size of the viewports and where curves go in which viewport and on which axis. Okay, so that was that was basic and custom plot layout. Let's talk about plot modification. And the first thing to know is plot modification happens after show plot. You can do all kinds of things as far as set viewport and axis labels and line styles and all kinds of things. But they have to be done after you call show plot. Because until you call show plot, the plot is not completely created yet. And so it won't work. You have to do all of this other stuff after show plot. Just keep that. That's just a rule. You got to know that. Okay. So after we call show plot, then we can get a viewport if we want to modify a viewport or something within a viewport. And when we say plot.getViewport, we have to give it an index number or a dataset name. And if we give it a viewport, that viewport is 0 based starting from the top. So the very top viewport is 0, the next one down is 1, the next one down is 2. If we don't want to get the viewport by name, by index, but we just want to get whichever viewport has this data set in it, then we can give it the path name of that data set. And so we can get the viewport by data set name. Once we have a viewport, we can get an axis. if we want to modify an axis or axis text or axis label. And so when we have a viewport, we can say viewport.getAxis and give it an axis name. The y-axes are y1 for the left, y2 for the right. You wouldn't necessarily get an x-axis out of a viewport. I guess you could. The x-axis is shared by all of the viewports for time series, since they are stacked on a common x-axis. And so x-axis name is here going to be y1 or y2 or x1 if you wanted the x-axis. Okay, axis set reversed. If, like in the workshop, we were going to have one of our viewports be upside down compared to the others. In other words, if we were creating a plot where it had precept, stage, and flow, but the precept we wanted to be in a hanging hyetograph because that's how we're used to looking at it, where the 0 precept is at the top left and precept increases down, then we would have to set that axis to reversed. There's a caveat, and I don't like it, but here's the ugly truth. If you want it to increase from top down, you have to set the reversed to false. There's a reason for that, and it has to do with the different orientations of computer graphics coordinate system versus engineering coordinate systems. Usually in engineering, on plots we start at the bottom, increase y as it goes up. In computer graphics, the origin or the 0 point of a screen is at the top left, and y increases down. And this set reversed here is with respect to the computer graphics orientation. I don't like it. You probably don't like it. It's confusing, but just know that if you don't set the reversed state, all of the axes, all the y-axes are reversed to true. That means they, from a computer graphics standpoint, they increase with y going up. If you want to change that for one of the axes, you have to set it to false. There, that's ugly, but I hate it. But there it is. Okay, so we can get a curve out of a plot. You might think we would get it out of a viewport, since that's how we set it into custom plot creation, but we don't. We get it from the plot. It's only going to be in one viewport, and so the plot knows where it lives. And so when you give it a data set name, it can determine where that curve is and return the curve to you in case you were going to modify the curve, like say set its line color. Now, on get curve, you can, instead of giving it the name, you can give it an actual time series container or a time series math, and it will get the name out of there. So it's pretty flexible. You can give it the data, or you can give it the name, and it will return you the curve that represents that data on the plot. Then you can go and set things about that curve. So you can set its line color. You can set, its line style. You see a link here and there is a place in the manual that lists things like all the color names that you can use. It's under plot component properties, and colors is a component of that. Okay, so we have modified our plot in every way, not every way, but we've shown you how to get to almost every way. And again, the plot modification, the link at the top puts you to where you can get to all of this information. And so we won't go over it in the lecture, but in the workshop it will refer you to some of them. There's one more thing about plot modification that we should mention, and that is axis markers. Just like you can do interactively, add a marker on an X or a Y axis, you can do that via scripting. Like so many other things, you have to import the class first. So we'll say add access marker, but before we do that, we have to say from HEC script import access marker. So again, this is a what I want to say. This is a plot modification. So where does it have to happen? After show plot. Now you can create your markers before show plot, but you can't add them until after show plot. So we create an axis marker, we give it an axis name, we give it a value, and it's interesting, the values always have to be strings. And so if it's a Y value, it's a numeric. If it's an X value for a time series, it's a date time. Regardless of which one it is, it has to be a string. So here in my example is quote 7.0, or it could be like quote 24JUN 2009, 02:00 for the x-axis. Anyway, so it's a strangeness, but it works fine. You can give it the text if you want any text along on the axis marker, and then you tell it what viewport to put it on. Now this is interesting. If you're setting it on the Y axis, then you'll set it on the viewport that has that Y axis. So if you have multiple viewports and one of the viewports has stage, you would set it on the viewport that has stage. However, if you are in a plot with multiple viewports and you want to add an axis marker on the x-axis and have it show up in all of the viewports, since they all share the x-axis, you have to manually add the axis marker. You don't have to create it once, but you have to add it to each viewport individually. And otherwise, it'll only show up in the viewport that you add it to, which is a strange look for a marker on the x-axis. We've covered a lot in this lecture, not just in this session, but in the lecture as a whole. So let's see where we got to. So these were our objectives: to become familiar with the automation capabilities of HEC-DSSVue. Like I said, there's two types of automation. We talked about this, it seems a long time ago now, but we talked about plugins and scripts and when you would use one and why you would use another and those types of things. And then we said, okay, now that we have that all figured out, we're not going to talk about plugins anymore. This entire lecture is going to be about scripts. We talked about creating and editing scripts. That very first session, we launched the script editor. We chose a script. We created a new script and gave it a name in the label field. Then we had an entire session. Session 2 was entirely about the script editor and all its pieces and parts, and then how and when to use an external editor, and the care that must be taken when you do that. After that, we talked about executing scripts. It was a little bit of a recap about the display controls, because they're tied one-to-one. Whether you can do the scripts menu, the script selector, or the toolbar. We saw that you could always execute a script from the script editor, regardless of what display controls are set. And the same is true, although we didn't say it, but we showed how to execute scripts from the command line. And the same is true about that. It doesn't matter what script selector, it doesn't matter what display controls are set. You can always execute a script from the command line. We talked about testing and debugging, and we saw that we're probably always going to have to test and debug. It's very, very unlikely to create a script from scratch and have it be perfect. So we talked about post-mortem debugging. Debugging by print. You output to the console log, and then you go look at it after the script runs and see what happened. We talked about runtime debugging, where it's kind of the same thing, except in putting stuff out to the console, we pop it up in a message box when it happens, and so that we can see what's going on when it's going on. And then we talked about the sophisticated source level debugging, that may be beyond the needs of some of us for writing scripts, but it's available to us. And we gave an example of using IntelliJ IDEA and setting it up as ChatGPT had told us to. Most recently, in the previous session to this one, we talked about scripting time series math operations. Remember, we talked about the two different types, two different flavors of time series and why they're there and what the differences are and when you use each one. And finally, just now, we talked about scripting plots, and we talked about basic plot creation. We talked about custom plot creation using a viewport layout object. And then we talked about modifying plots. The main point to remember is you have to call showPlot first before you can modify anything, and then you can go on your way modifying plots, including adding axis markers. So that's it. That's the entire lecture for scripting in HEC-DSSVue, and hopefully you've got enough under your belt to get started and to become successful in all your scripting endeavors.